In this video we have some miscellaneous exercises dealing with derivatives and integrals. There's 9 problems altogether. You can pause the video as I go through it in case you want to try them. So for the first one we have y equal 3 cosine of 3x plus 1. I want to find the derivative. I'm going to use y prime here to denote the derivative of y with respect to x. So we have a constant there. So the derivative of cosine is minus sine. So I'll start with that. This will still be 3x plus 1. And then I got to use the chain rule, multiply by the derivative of this 3x plus 1. This will give me 3. And then of course I already had a 3 out here. So this will give me a minus 9. So I get the derivative is equal to negative 9 sine of 3x plus 1. Now for the next one I have a product, x and sine of x squared. So here I have to use the product rule. So let's do it this way. It's the first one, say, times the derivative of the second one. So this will be x, and the derivative of sine is cosine. So this will be cosine of x squared. And of course now, because we have the x squared there, we have to multiply by the derivative of x squared using the chain rule. So this will give me a 2x out here. And then it's plus the second expression times the derivative of the first. So this will be sine x squared times the derivative of x. That's 1. So that'll just give me sine of x squared. And just simplify the first term a little bit here. 2x times the x here will give me a 2. X squared times the cosine of x squared plus sine of x squared. And that's your derivative for the second one. Okay, for number 3 we have y equal to x times tangent x. That means we have a product here. So this will suggest a product rule. So it's y prime, and it's the first function here. X times the derivative of the second. The derivative of tangent x is secant squared. And then it's the second times the derivative of the first. Derivative of x is 1. So we wind up with this answer. Okay, the next one, we don't have a side for y here, so let's rewrite this. Add negative 2 to both sides. We get this. And then let's solve for y by taking the sine inverse of both sides. So sine inverse of the right side will just give me y, so I'll put this on the left then. And then sine inverse, or I can say arc sine, of x minus 2. Let's take the derivative here, then y prime, or dy over dx. This will equal 2. And the formula is 1 over the square root of 1 minus. It's just like your u here. So it's the square root of 1 minus x minus 2 squared. And then of course it's the derivative of this expression here, but the derivative of x minus 2 is 1. So that will leave me with that. That's your derivative for that one. And then for number 5, got the derivative of arc secant. And this is going to be 1 over, and then this is your u in the formula, and it's absolute value of u, but e to the 2x is always positive, so we don't need absolute values here. Get that. And then it's the square root of, that's u squared under here, so u squared, it's e to the 2x squared, so that's e to the 4x minus 1. And then it's the derivative of the u, which in this case is e to the 2x, so this will give me a 2 e to the 2x. Because the derivative of e to the 2x is e to the 2x, but then you're going to multiply by the derivative of the u using the chain rule. We get this 2 here, and of course these will now cancel, and I simply get 1 over the square root e to the 4x minus 1. And I need the 2 up here. And this is the answer to this one. And now we have some problems involving integration here. So this one looks like a typical u substitution here, because I know the derivative sign is cosine. Let's let u equal to sine x. Then du will equal to derivative of sine is cosine, and then we have the dx here. Now let's rewrite this integral. So cosine dx, right here, cosine dx is your du, transforming it to an integral involving u instead of x. And this is 1 plus sine squared, but sine is u, so this would be u squared. And this is the formula that leads to the arctangent. So this is going to be arctan. And look at this as the 1 or 1 squared. The formula is u squared plus a squared. So in this case the a is 1. So the formula says if it's in this format, and you have it in this setup here, the integral will be arctan of u over 1. So what is u? Let's go ahead and convert it back to the variable. So u is sine x over 1. So sine over 1 is still sine. So I just leave it this way. And then the coefficient is 1 over a. But a is 1. And the coefficient here is 1. 1 over 1 is 1. So this is your answer, plus the constant of integration. You got the integral of arctan of 2x dx over 1 plus 4x squared. And on this one, I'm going to let u equal to arctan of 2x. And I'm looking ahead here because I know that the derivative, so be du, will equal to the derivative of arctan of an angle is 1 over 1 plus u squared. This is your u here in the formula. So this 2x squared is 4x squared. And then it's using the chain rule. Going to take the derivative of 2x, that's 2, so this will be 2 times 1. So 2 times 1, I just change this to a 2. And then this will be dx. So let's solve for dx then here. Dx, multiplying both sides by 1 plus 4x squared, so this will give me 1 plus 4x squared, and then I got du, and then I got this 2 over here, so I got this 2 right here, so I divide by 2, so I'm going to put the 1/2 here. You got this. So now we come back to this one over here. This is the integral, and arctan of 2x, that's my u. I just put a u up here. And then the dx is replaced by this. So what I'm going to have 1 plus 4x squared, but I have 1 in the have that same thing in the denominator, so those are going to cancel out. Those are going to cancel out. Then I'm going to have the 1/2 out here. So I can just take out this fractional bar here. So with that substitution, the integral reduces to 1/2 the integral of u du. Now, basic integration here, this will be 1/2, and then the integral of u with respect to u is u squared. Add 1 to the exponent, then divide by that number, 2, plus the constant of integration. And then this will equal 2. Multiply this out, this will be a 1/4. And now we just go back to the original variable. So here u is arctan of 2x. And that is squared. Plus the constant of integration. And that's your answer for this one. Okay, for number 8, got 1 over e to the 2x plus e to the minus 2x. Let me rewrite this. I'm going to multiply the numerator and denominator by e to the 2x. So I'm multiplying by e to the 2x here. Numerator and denominator. So in the numerator, I'm just going to get e to the 2x. In the denominator, when I multiply by e to the 2x, I get e to the 4x. And then e to the 2x times e to the minus 2x is e to the 0, which is 1. This is dx here. Now I'm going to think of this e to the 4x. I'm going to do it this way. It's e to the 2x quantity squared. That's the same thing as e to the 4x. And I'm going to let u equal to e to the 2x. So du will equal to the derivative of e to the 2x is e to the 2x. Using the change rule now, I'm going to take the derivative of 2x, which will give me 2. Put a 2 out here, and this is dx. Now we transform this integral here. Okay, here I can divide by 2, so let's divide both sides here by 2. I'll put the 2 under the du on the left side. So e to the 2x dx, that's the part of the numerator, can be replaced by du over 2. But I'll put the 1/2 out in front here. And then in the denominator I have e to the 2x squared, but that's e to the 2x is u, so this will be u squared plus 1. So you can look at this then as there's a formula, integration formula, that has the integral of du over u squared plus a squared. So think of the 1 as 1 squared. That would be a, would be 1 then. And it tells you that the integral of that would be arctan, that's the inverse tangent, of u over a, so it'd be u over 1, which is u, but u is e to the 2x. And then the coefficient is 1 over a, but a is 1, so this is just going to be a 1 plus the constant of integration. And of course I have my 1/2 here. 1/2 is also divided by 1, but that's still going to be 1/2. So final answer is 1/2 arctan of e to the 2x plus c. And then probably the easiest of the integration problems is the last one, because the derivative of secant is secant tangent. And of course you have the angle. In this case it's 2x. So if I just said what's the integral of secant tangent, the integral of secant tangent is secant. of the angle. Because the derivative of secant is secant times tangent of the angle. Now if this were an x, then this would just be secant x plus constant. But it's 2x, so you have to consider, in this case, the u equal to 2x. du would be, derivative of 2x is 2 dx. So you would replace the 2x by u, and of course the dx would be du over 2, so the only difference is you could have this extra factor of 1/2 here. This one is pretty basic, plus your constant of integration. That's the answer to the last one. Thanks for watching. We'll see you next time.